That afternoon, we discovered our rig was tripping the circuit. Nothing was powering up, and we had no idea why. We couldn't run the tests we wanted until we solved this problem. Eli and Seth had a theory.
The way it works is with all of these plugs, the three-pronged plugs, you have a hot, a neutral, and a ground. So hot is where the power comes in, and then neutral is where it should go, and then ground should not have any current flowing through it. If you look at the actual plugs, you can see it better. The small one is hot, and the big one is neutral. All of the current flowing out of hot, as I said, into neutral. And what a ground fault current interrupter does is it monitors how much current is coming out of hot and how much current is going into neutral. If those numbers aren't the same, it'll just stop the power from flowing. Right now, what we have set up on our solenoid valves right now is power comes out of hot and then into ground. So if we go and plug it in,
the numbers from the first thing are not the same, thereby that's why your power is shutting down?
Yeah, because like it sees that power is coming in through hot, and then it's not seeing that power go back into neutral because it's going to ground. It's a non-GFCI, we think it'll work.
Okay, so then what is your next step?
Then we know it's the GFCI.
And not something else.
We need to switch those two wires.
Yeah, the wiring on here is going out of hot and into ground, as we said, for the solenoids. So we need to change the wiring.
Okay, so that's best case scenario then, right?
Yes.
Correct. Okay.
That is ideal.
But if it doesn't work when we plug it into a non-GFCI,
GFCI.
then we don't know. Then we got no clue and we're back to ground zero. Okay.
Yeah, pretty much.
After plugging it into a non-GFCI, it worked. Then we switched the wires, Eli soldering them into place. After that, we tested the rig on the tower, which simulates the kind of power system that is on the plane, and...
Yes, I'm just taking it ready.
Hey Eli, we're ready.
Okay.
Coming up, but there's a little
Good? We're good.
Yay! We got back to the hangar only to discover one of our PZT sensors wasn't responding.
So what we think we have is a faulty sensor, which is really problematic because we have our wiring going through the bulkhead already.
Right.
So we had another sensor that had its own BNC, so one of the big black cables that we hook up to the DAQ, but we can't use that because we need to go through the bulkhead. So what I had to do is cut the leads from our bad sensor, cut the leads from the other sensor, and rewire them together. Now I'm going to have to solder them together.
In here.
In the rig. If I could have someone over here to hold the stand.
There you go, Daisy.
Beautiful.
Alright, good?
Let's close her up.
Look at that beautiful thing.
And by close her up, I mean I need electrical tape. Please tell me this is not going to be the most difficult part.
The white tape kind of...
Warm.
Mission accomplished. Finally, we could add on the padding, check the weight of the rig, and send it off for load-in. We had to wait and see if the rig fit on the plane because there were 4 bolt holes that had to fit perfectly in order to secure the rig. Once we were told it was in, we were all clear. We could relax. Well, for now. At least until next week, then we could finally see our experiment in action. And we would finally get to fly.
Normally do it from like 5 inches away, and I'm now doing it from 2 feet away. So
Welcome to literal rocket surgery.
It's not a
shut up, Eli.
rocket.
Rocket surgery.
It's a plane.
This isn't a plane.
This isn't
not
even
a
a plane.
Who said that earlier?
What?
Rocket surgery.
Kyle.
Crosby.
Crosby?
It's not rocket surgery.